So now let's do the 6 steps to inferential statistics for an independent t-test. In other words, we're going to look at 2 separate samples and run them in an independent t, and we're going to pay particular attention to how to do this in JASP, because I hope that you'll notice that the rest of the 6 steps pretty much stay the same. So here's our prompt. Researchers wanted to know if men and women take the same amount of time to get ready for a date. They asked 16 men and 18 women to tell them how long in minutes they took to get ready for a date. Do the 6 steps to inferential statistics to see if men and women differ in the time it takes to get ready for a date. So first thing I'd like to point out is there any prior research in this prompt? Nope, doesn't look like it. So we are not justified in doing a one-tailed test. So if our research question is, do men and women differ in the time it takes to get ready for a date, which I hope you noticed I took from the prompt, what would our null hypothesis be? Would it be that men and women differ in the time it takes to get ready for a date? Men and women do not differ in the time it takes to get ready for a date? Men and women do not take the same time to get ready for a date? Men and women do not differ in the number of dates they take. Now, if the answer isn't screaming out at you, let's do a process of elimination and see which ones we can remove. What do you think about D? Men and women do not differ in the number of dates they take. That's a totally different topic, so we know that we can cross D off. What about C? Men and women do not take the same time to get ready for a date. Now, it's not ideal to use the word same because then we feel like we get into these double negatives. But it's okay, you're allowed to use the word same. But what is the null hypothesis? The null hypothesis is no difference. So another way of saying no difference would be that they are the same. So this one's saying men and women are not the same. See, that's the opposite. So C would never work. So now we're debating between A and B. Which one of these implies no difference? So it would be B, right? Do not differ. So now we have to define our rejection region. And here's where it gets a little different than what we've done before. So we have 16 men and 18 women. And hopefully you remember that our degrees of freedom are calculated as n minus 1. But we've got 2 sets of n's, so we have to do it 2 times. So here's how we do that. We take the n minus 1 for the men and the n minus 1 for the women, and we add them together. So it's 16 minus 1, which is 15, plus 18 minus 1, which is 17, and those add up to 32. The reason we lose 1 for each is because I'm going to calculate the mean for the men and the mean for the women. You lose 1 degree of freedom for each mean you calculate. Another way of thinking about it is the total sample size, 16 plus 18 minus 2. So this is 34 people were in our study, and we lost 2 degrees of freedom for each of their means, so our degrees of freedom are 32. So now we want to look at 32 on our t-table, and remember we decided it was 2-tailed. And if I scroll down to this table, you'll notice they don't have a 32. It jumps from 30 to 40. And it's okay that they did that because you'll see it's a very subtle difference. When from 29 to 30, you see how the difference is very subtle. So from 30 to 32, it actually would probably not even show up. It would be 2.042, blah, 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 blah. So when you come across a situation where you don't have the exact number, you round down because that makes it more conservative, it makes it harder on the researcher. So since we don't have a 32, we're going to round down to 30. Oh, shoot, my eye saw that as 2.52. Let me see if I can correct that real quick. Okay, I repaired that. My eyes are getting old. I had seen 2.52, but this is a 2.042. So our T critical is 2.042. So now let's ask what the rejection region is. Do we define the rejection region as more than 2.042? Is it less than negative 2.042? Is it more than 2.042 or less than negative 2.042? So as I put them together. Or is the rejection region plus or minus 2.042? So I'll give you a minute to think about it and pause if you really need to debate. Don't wait for me to give you the answer. I would love for you to come up with it on your own. So hopefully you know that A and B are not right because those are one-tailed. So more than 2.042 would only ever be right. And actually this isn't even a rejection region for the one-tailed, but this would be an upper tail, this would be a lower tail, but then these would be the wrong numbers, right? We'd have to go look at the one-tailed test. So in this case, C is the right answer because we want to combine them, more than 2.042 or less than negative 2.042. The reason I put this one here is I often see people defining their rejection region as plus or minus 2.042, and that's not a rejection region. Those are two numbers. So you're basically saying you only reject the null if you get exactly 2.042 or exactly negative 2.042. So while this is our critical T, it does not define our rejection region. The answer here is C. That defines our rejection region. All right, now here comes the fun part where we're going to do step 4, which is calculating our observed T. So let's go ahead and go there. So I went ahead and opened up the data set, and if you're not sure how to do that, go back to some of the other videos where we reviewed that. I'm going to assume you know how to do this by now. And the only thing I want to fix before we get started is it's okay that gender is nominal because this is male and female, and that should be nominal. So the Venn diagram is appropriate. But time, that's a number. And I want to make sure that JASP knows it's a number because it will change the statistics that it allows me to do. So to do that, I'm going to go up to this Venn diagram, click on it, and change it to scale. So that ruler is a reminder that rulers are used for numbers. And if you set these up appropriately, then JASP will allow you to do the appropriate calculations. If you leave it without making sure these are right, then you won't be able to do the proper calculations and you'll be confused. Okay, so now we want to do an independent t-test. What do you think we're going to click on? T-tests. And then what do you think we're going to click on? Independent sample t-test. Okay, so here this looks a little different than we did for the dependent t. So I want to highlight what we're going to do. The dependent variable, this is the outcome variable, that always goes up here. And you can tell the ruler is going to be matched up with the ruler. So time is our outcome variable. Remember, the dependent variable is our outcome variable. And so in this story, we started with gender and then we looked at the time they took. Our grouping variable is now gender. So, and you can see that it's saying, I will accept these kind of data, and gender will now go down here for grouping. So what we have over here in our output is very straightforward, and it's much like we saw with the dependent t, where we have our calculated t, our degrees of freedom, we agree that it was 32, and then here's that p-value. So our observed t is negative 2.783, and I'm going to come back to that in just a second, but I wanted to point out that this p-value, because it's less than 0.05, we know we're rejecting the null. Just as we did with the dependent t, if you wanted to change these to one-tailed, this is where you would do it. This particular story is two-tailed, so we'll leave it like this. But if we had made it an upper-tailed test or a lower-tailed test, we would make those changes here. Again, it won't change the t calculation, but it will change the p-value. I do encourage you to click on descriptive so that you can have your information. And then now let's talk about this t. What this t is doing is it's entering the first variable that you have in your gender variable first minus the second. So what I can see here is they entered female minus male. That might be okay with you. Usually you want to have the first variable be the one that interests you most. So let's say this was drug versus no drug. Do you see how drug would interest us most? Then it should be drug first, then no drug. And that's because then if we do drug minus no drug, and it's a positive number here, we know they went up. So it's not mandated that you put those first. However, it is a good rule of thumb. Now, if you don't dictate the order, JASP will do alphabetical order. See how female is coming before male because it's alphabetical. If I go back to the column, you'll see I actually entered males first, but JASP does it alphabetically. Let's say I was actually more interested in the males. Let's say I think males are going to be different. I really want to see what the males do. So if you are interested in the males and you want to interpret how the males do, here's how you would do that. Now, again, if you're in the newer version of JASP, you don't have this OK button. It just kind of stays like this. And so you would have to get back to your data, kind of start over. But here's how you would change the order. You would click on the word gender and see how it has female first. I would switch those so that male is first. because let's just say I'm really interested in what the males do. Females, I don't care. I want to know how the males differ from the females. So if I get out of here and then rerun my test, and I put time here and gender, now notice that my T is exactly the same. My degrees of freedom, my appeal are exactly the same, except now it's a positive number. So because I put males first, and I know that I did that because in my descriptive, see how it's listed as males first? Now I know that males took longer than females. How did I know that? Because this is a positive number. Males minus females is a positive number, which means males took longer. You can also see it in the mean reports, right? The males took 69.5 minutes and the females took 58.67 minutes. So this will be important to help you interpret, and it becomes vastly important if you're doing a one-tailed test. Because if you're doing a one-tailed test and you reverse the order, then this negative value might be supposed to be positive. So you'll definitely want to get in the habit of realizing which variable is going first so you know whether to interpret this as a positive T or a negative T. So I'm going to go back to our slide so we can finish up our 6 steps. Okay, so now we did step 4 and we found our T calculated, or our T observed, to be 2.783, and we had to have a rejection region of 2.042 and higher or negative 2.042 and lower. Let's decide what we're going to do with the null. Are we going to reject the null, fail to reject the null, accept the null, or accept the alternative? So hopefully you realize we're always going to cross off C and D. We'll never accept anything ever. So now we have to decide between rejecting the null and failing to reject the null. Since the 2.783 is higher than the 2.042, we're going to reject the null. So A is the right answer. So here are our 6 steps. Do men and women differ in the time it takes to get ready for a date? The null is that they do not differ, and the alternative is that they do differ. Our rejection region is more than 2.042 or less than negative 2.042. Our observed value was 2.783. I rejected the null. Now, if I reject the null, I cross it off. You might have said I wanted to say men and women differ in the time it takes to get ready for a date. But if I call my grandma and say, Grandma, I found out men and women take a different amount of time, she's going to want to know what the answer was. So you're going to have to tell her. You see how it would be the same if I said men take longer to get ready for a date as it would be to say women take less time to get ready for a date. So you spin it however makes most sense to you. Now, sometimes we'll be talking about something like a drug versus a placebo, and it'll make most sense to talk about the drug. You know, the people who took the drug lived longer. But for something like men and women, where what interests you could, you know, I might be interested in talking about the men and you might be interested in talking about the women, you make sure that we're essentially saying the same thing. I say men take longer, you say women take less long. That's the same thing. All right, so notice that these steps didn't really change that much, except we had a little bit of wiggling to do to get our rejection region because we had an extra N for our degrees of freedom, and really the hard stuff was in JASP and it did all the math for you. So now let's do the 6 steps to inferential statistics for an independent t-test. In other words, we're going to look at 2 separate samples and run them in an independent t, and we're going to pay particular attention to how to do this in JASP, because I hope that you'll notice that the rest of the 6 steps pretty much stay the same. So here's our prompt. Researchers wanted to know if men and women take the same amount of time to get ready for a date. They asked 16 men and 18 women to tell them how long in minutes they took to get ready for a date. Do the 6 steps to inferential statistics to see if men and women differ in the time it takes to get ready for a date. So first thing I'd like to point out is there any prior research in this prompt? Nope, doesn't look like it. So we are not justified in doing a one-tailed test. So if our research question is, do men and women differ in the time it takes to get ready for a date, which I hope you noticed I took from the prompt, what would our null hypothesis be? Would it be that men and women differ in the time it takes to get ready for a date? Men and women do not differ in the time it takes to get ready for a date? Men and women do not take the same time to get ready for a date? Men and women do not differ in the number of dates they take. Now, if the answer isn't screaming out at you, let's do a process of elimination and see which ones we can remove. What do you think about D? Men and women do not differ in the number of dates they take. That's a totally different topic, so we know that we can cross D off. What about C? Men and women do not take the same time to get ready for a date. Now, it's not ideal to use the word same because then we feel like we get into these double negatives. But it's okay, you're allowed to use the word same. But what is the null hypothesis? The null hypothesis is no difference. So another way of saying no difference would be that they are the same. So this one's saying men and women are not the same. See, that's the opposite. So C would never work. So now we're debating between A and B. Which one of these implies no difference? So it would be B, right? Do not differ. So now we have to define our rejection region. And here's where it gets a little different than what we've done before. So we have 16 men and 18 women. And hopefully you remember that our degrees of freedom are calculated as n minus 1. But we've got two sets of n's, so we have to do it 2 times. So here's how we do that. We take the n minus 1 for the men and the n minus 1 for the women, and we add them together. So it's 16 minus 1, which is 15, plus 18 minus 1, which is 17, and those add up to 32. The reason we lose 1 for each is because I'm going to calculate the mean for the men and the mean for the women. You lose 1 degree of freedom for each mean you calculate. Another way of thinking about it is the total sample size, 16 plus 18 minus 2. So this is 34 people were in our study, and we lost 2 degrees of freedom for each of their means, so our degrees of freedom are 32. So now we want to look at 32 on our t-table, and remember we decided it was two-tailed. And if I scroll down to this table, you'll notice they don't have a 32. It jumps from 30 to 40. And it's okay that they did that because you'll see it's a very subtle difference. When from 29 to 30, you see how the difference is very subtle. So from 30 to 32, it actually would probably not even show up. It would be 2.042, blah, 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 blah. So when you come across a situation where you don't have the exact number, you round down because that makes them more conservative, it makes it harder on the researcher. So since we don't have a 32, we're going to round down to 30. Oh, shoot, my eye saw that as 2.52. Let me see if I can correct that real quick. Okay, I repaired that. My eyes are getting old. I had seen 2.52, but this is a 2.042. So our T critical is 2.042. So now let's ask what the rejection region is. Do we define the rejection region as more than 2.042? Is it less than negative 2.042? Is it more than 2.042 or less than negative 2.042? So as it put them together? Or is the rejection region plus or minus 2.042? So I'll give you a minute to think about it and pause if you really need to debate. Don't wait for me to give you the answer. I would love for you to come up with it on your own. So hopefully you know that A and B are not right because those are one-tailed. So more than 2.042 would only ever be right. And actually, this isn't even a rejection region for the one-tailed, but this would be an upper tail, this would be a lower tail, but then these would be the wrong numbers, right? We'd have to go look at the one-tailed test. So in this case, C is the right answer because we want to combine them, more than 2.042 or less than negative 2.042. The reason I put this one here is I often see people defining their rejection region as plus or minus 2.042, and that's not a rejection region. Those are two numbers. So you're basically saying you only reject the null if you get exactly 2.042 or exactly negative 2.042. So while this is our critical T, it does not define our rejection region. The answer here is C. That defines our rejection region. All right, now here comes the fun part where we're going to do step 4, which is calculating our observed T. So let's go ahead and go there. Okay, so let's do our independent t-test. So the first thing we're going to do is click Analyze. Then I'm going to scroll down to Compare Means and Proportions, and then we're going to scroll to Independent Sample t-test. So our test variable is our outcome variable. So that's going to be the one that's marked as a ruler or nominal and, sorry, not nominal, ratio and interval. So that's going to be time. So our number outcome goes here. And then our grouping variable is going to be gender. So that's going to go down here. Then we're going to define our groups. Group 1 is male
and group 2 is female. And now we click OK. So now we can see we have some descriptive statistics up here. We have our sample size for both groups. We have the means, the standard deviation, and the standard error, the mean for both males and females. And then what we can see here is using the equal variances that are assuming equal variances, we can see that our calculated T is 2.783. Our degrees of freedom are 32. If we had a one-tailed test, our p-value would be 0.004. If we have a two-tailed test, our p-value is 0.009. So this T equals 2.783 is what we're going to use for our 6 steps for inferential statistics.
Okay, so now we did step 4 and we found our T calculated, or our T observed, to be 2.783. And we had to have a rejection region of 2.042 and higher, or negative 2.042 and lower. Let's decide what we're going to do with the null. Are we going to reject the null, fail to reject the null, accept the null, or accept the alternative? So hopefully you realize we're always going to cross off C and D. We'll never accept anything ever. So now we have to decide between rejecting the null and failing to reject the null. Since the 2.783 is higher than the 2.042, we're going to reject the null. So A is the right answer. So here are our 6 steps. Do men and women differ in the time it takes to get ready for a date? The null is that they do not differ, and the alternative is that they do differ. Our rejection region is more than 2.042 or less than negative 2.042. Our observed value was 2.783. I rejected the null. Now, if I reject the null, I cross it off. You might have said I wanted to say men and women differ in the time it takes to get ready for a date. But if I call my grandma and say, Grandma, I found out men and women take a different amount of time, she's going to want to know what the answer was. So you're going to have to tell her. You see how it would be the same if I said men take longer to get ready for a date as it would be to say women take less time to get ready for a date. So you spin it however makes most sense to you. Now, sometimes we'll be talking about something like a drug versus a placebo, and it'll make most sense to talk about the drug. You know, the people who took the drug lived longer. But for something like men and women, where what interests you could, you know, I might be interested in talking about the men and you might be interested in talking about the women, you make sure that we're essentially saying the same thing. I say men take longer, you say women take less long. That's the same thing. All right, so notice that these steps didn't really change that much, except we had a little bit of wiggling to do to get our rejection region, because we had an extra N for our degrees of freedom, and really the hard stuff was in JASP, and it did all the math for you.